Good morning, students. So for those of you who missed our PowerPoint presentation this week, I wanted to make this for you so you had an idea of what you missed and what needs to be completed. So we are looking this week at energy transfer. So we move on to investigation 5 after being on investigation 4 last week, where we talked a lot about kinetic energy. And so something I want to mention first is we have a new club that's coming back, not a new club, a club that's been around, but we are bringing it back this year called Science Olympiad. And it's a competition where you choose what test or what competition around science you want to compete in, and you work at it for the next couple months until March when we compete at a high school in Stockton. So watch this video on your own time. You can click it right from the presentation. And if it seems like something you're interested, let me know or one of the other science teachers know by Thursday or Friday of this week. So first thing I want to talk about, energy transfer. So what is a thermometer? We're going to be using a thermometer to explain energy transfer this week. And so what a thermometer breaks down to when we look at the words is thermo and meter. In science, whenever we hear the word thermo, you should always think heat. Thermo means heat in science. And a meter is anything that measures, right? A measurement device, such as an odometer that you see in your car that measures the speed you're going, or even a gas gauge in your car. Those are all meters, and they tell you a measurement of some sort. So when we look at thermometer, we are measuring heat, a thermometer. And what a thermometer specifically looks at is the kinetic energy of the substance it is measuring, okay? And we know all about that word, kinetic energy. So to start off, I have added a video about how thermometers are made. And so you can click on this also on your own time. It's about 5 minutes long, and it just gives you an idea of what goes into a thermometer and how it's made so you can understand it better as we go along. Now, very important is vocabulary this week. So we have some new words that are being introduced. And these words you don't have to memorize, but you do need to recognize them. And if you read through them, you need to know which one they are, because these will be on your quiz at the end of the week. So our first word, conduction. This is a new one. Conduction is a transfer of energy, heat, from one particle to another as a result of contact. So when two things touch, they come into contact with one another. So when we've been talking about these gas particles, these liquid particles, and the solid particles, we know that they move around each other. Solids vibrate. They don't move, but they vibrate. Anytime they touch each other or come into contact, they're transferring energy. And when it's by contact, we call that conduction. Now, cooling. Cooling is an energy transfer that decreases the kinetic energy of a substance's particles. So when we decrease the kinetic energy, it's cooling, right? And we've seen that when we put the air bottle, the bottle full of air with a balloon, inside of a cold water bath. We know we were decreasing the kinetic energy, right, by using that cold water, and that's cooling. Now, energy transfer is the movement of energy from one location to another. So when two particles hit each other, they're transferring energy from one particle into the other. Generally, the one with more energy is going to transfer its energy to the lesser particle until they're even. So conduction and energy transfer go together, right? Conduction is the energy transfer, or the transfer of energy from one particle to another. So recognize that and be familiar as we go through the week. Next, we have equilibrium. And so equilibrium is a condition in which a system is experiencing no net change. So if you imagine opening a door to the outside and letting a bunch of cold air into your room, eventually that cold air and that warm air are going to mix together, and those particles will hit, and the room temperature will all be the same again, but it'll be a little cooler than before because you let in cold air. So once those particles, the cold and the warm, mix, and they all hit and have the same kinetic energy, and the temperature is now the same in the room, we have come to an equilibrium. a condition in which a system, like our room, is experiencing no net change. And what that means is the kinetic energy is going up or down. We aren't getting hotter or colder. On Thursday and Friday, we'll look into this more. Lastly, we have heating, energy transfer that increases the kinetic energy of a substance's particles. All right, so the activity that we went through in class, I want you guys to log into fosweb.com, and you're going to open up and work through the thermometer activity. And so I put a picture here of what your screen should look like when you log in. And so we'll do the thermometer activity, and let's take a look at that now. So once again, when you log into FOSWeb, you have this view, your student view, and over here on the left, we're going to click on thermometer. That's going to open up this page for us. And so we have this activity we want to work through. We have a glass thermometer filled with red alcohol, and it's in a pot of water. And so they've made a close-up view right here for us about what we're seeing. And we have the red particles, which are alcohol particles inside the thermometer, and alcohol is a liquid. Then we have the glass layer, the glass particles in gray. And we know glass is a solid, right? When you hold a thermometer, that's solid. And so we see these solid particles in gray, and they aren't moving, they're only vibrating. And that should be familiar to you because last week, when we talked about the particles between substances, so the three phases of matter, right? We have a solid, a liquid, and a gas. And so we know our liquids are the red and blue particles here, and they move around each other, right? They can move on to different particles, but they're attracted, and they stay close together. With solids, solid particles are stuck together, right? They don't move. They don't fly around through the air. They don't move around each other. They're stuck in position because of their bonds. And so all that solids can do is vibrate. And that's what we're seeing right here in this picture. We have our particles vibrating, the solid particles. And that's the glass and gray. And then finally, on the other side, as you can see in here, we have water particles. And those water particles are moving all around each other, but they're still bonded as well, right? They aren't a gas. So the first thing we're going to do is we're going to heat water. And so we click the heat water, and it's going to tell us that energy from the heater's down here, transfers to the water molecule. So we have that energy transfer, right? One of our vocabulary terms. Energy transfers from heat to the water. And as you can see in this picture, we know when we heat water molecules, they speed up and they move faster, and that causes them to bump into each other more as they're moving faster. And so when we click next, now you can see the glass particles are vibrating faster. So fast-moving molecules, the water, hit the glass thermometer bowl. Energy from the water transfers to the molecules in the glass of the thermometer bowl. The glass molecules move faster. So once again, we know that when we increase the kinetic energy of a substance like water, a liquid, they move faster. But then they collide into the glass of the thermometer bowl, and that's where we get our energy transfer. And what word from our vocabulary goes along with that? Conduction, right? Conduction is when particles hit and transfer energy. And what are water particles doing with the glass particles? They're hitting them and they're transferring energy. And when we have kinetic energy being transferred by heat, we're heating it up, we're increasing kinetic energy of everything that comes into contact with these particles. So first our glass particles speed up, and then when we click next, the alcohol particles speed up. And as you saw over here on the left, we know when liquids expand, when liquids increase in kinetic energy, they expand. So the liquid inside the thermometer, because it was getting hot, expands and moves up. And that's where we get our readings on a thermometer from. So vibrating glass molecules hit the alcohol molecules inside the thermometer bulb. Energy transfers to the alcohol molecules. The alcohol molecules move faster. The alcohol expands and moves up the thermometer stem. And then next, we're going to cool it back down. We're going to go back and hit cool water. And so as the water cools down, it loses energy, right? We aren't gaining kinetic energy from the heater anymore. So when the heater is turned off, energy radiates from the water to the environment. The water molecules have less energy and move more slowly. So when it says the energy radiates from the water to the environment, all that means is that we're losing energy to the air. So this hot water, because it's not gaining energy anymore from the heater, the energy begins to be lost into the air. And so these particles then slow down, and because their kinetic energy is decreasing, they're hitting the glass bulb, which causes that to decrease. And so those particles now slow down. So the glass molecules transfer energy to the cooler water. The glass molecules have less energy and move more slowly. And last, because the glass is moving slower, the alcohol cools down and it moves back down the stem because it is contracting once again. So the alcohol molecules transfer energy to the cooler glass. The alcohol molecules have less energy and move more slowly. The alcohol contracts, our vocabulary term from last week, and moves down the thermometer stem. So once again, if you need to go through this, feel free to watch this video as many times as you need, but this is a very important concept we are trying to understand now. That conduction is when we have that energy transfer between the particle collisions. So those water molecules colliding with the glass in the bulb causes them to gain kinetic energy and move faster and faster, and then transfers to the alcohol. And that's where we get our expanding in the thermometer. So let's head back to the PowerPoint now. After you've completed that, what we want to do is come to this slide. And what we're looking at now is the same picture we had before from the video. And so after you've completed this, our next step is to log into FOSWEB. So we have a reading that's really important to do. And you can click on this link, and this link will bring you directly to FOSWEB, to where you can log into your student page. FOSWEB has been loading very slow, just be patient. And so we want to click on My Student Page when you log in. And that brings you to something that looks just like that slide go. Just like this, once again, so where we click the thermometer, but this time we're going to click the ebook. So let's see if we're loaded yet. So we click the chemistry book. And then we want to do our reading in the ebook. And now if you're a Spanish reader, you're welcome to do it in Spanish. Click the interactive ebook, HTML, but we're going to go with the English version today. And I've already loaded it. Let's hope it's loaded here. It is not yet. So on page 36 is where you will go for your reading. I'm sorry, page 46 to 55. And you will do the reading there. And once you're done on FOSWEB, you will come to answer this question, and this is where your 10 points for today are going to come from. So on slide 8, I want you to put everything we've talked about together. This picture above, the thermometer particles, this is from the reading. So it's very important, once again, that you go to page 46 in your reading book on FOSWEB and do the reading that goes along. Because, once again, your question for today is using this picture above. So using this picture, explain to me how energy transfers into a thermometer. So remember, it starts with the particles outside, it continues to the particles, the glass of the bulb, and then to the inside. So I want you to explain that to me. But what's really important, and I've attached a rubric to your assignment, is that you use vocabulary terms, you use complete sentences, and you also get the point across of what I'm looking for. So we have a rubric here, and this is how I'm going to grade your responses. If you do not attempt or write anything on the PowerPoint slide, you will get 0 points. If you make an attempt, but it's an unfinished or incomplete answer, you'll get 2 points. If you attempt, but the sentence is still incomplete and the main idea of energy transfer through particle collisions is not fully understood, you're going to receive 4 points. Now, if you attempt a complete answer, but the main idea of energy transfer through particle collisions is not completely understood, but you have that complete sentence, you'll get 6 points. And if you have a complete sentence, the main idea is understood, but you do not use a vocabulary term in your answer, such as conduction, kinetic energy, or energy transfer, you'll still get 8 points, but you'll miss out on those final 2 because you didn't use vocabulary. So in order to get a full 10 points, you must do a complete answer with a complete sentence. You must get the main idea into your answer, that energy transfer through particle collisions, our word conduction, is understood, so I understand that you get it, and you must use vocabulary such as conduction, kinetic energy, or energy transfer in your answer, and that'll be a full 10 points. So what you need to do to get 10 points is right here. Make sure you add that into your answer, and once again, the way you answer that is on your PowerPoint slide here. So when you click on it, you can edit your document directly in Teams. So we click Edit Presentation, and we're just going to edit in Browser. And that will reload your PowerPoint so that you're able to type in it. Some of you are able to type right in immediately. Some of us have to click on that. So now we want to go down to slide 8, as mentioned before, because that's where our question is. And then we just double click. And so you're able to type your answer here. I hope this little tutorial helped. If you still have questions, definitely come ask. I don't want anyone missing any points. And there is no homework for today. So your homework, you can think about how great science class was and everything you learned today. And that's fine by me. That's your homework assignment. So we don't have any points for homework today. Your 10 points are going to come from your assignment by answering this question in the PowerPoint.